Hello, this is Chupak Lalit Prem Gajavelli from Institute of Aeronautical Engineering, Dundigal, Branch CSC Cybersecurity, roll number 22951A6216. This is my AAT conceptual video for Basic Electrical Engineering BEE subject, and the topic I've got is KVL, which is Kirchhoff's law, which is Kirchhoff's voltage law and its applications. Kirchhoff's laws. Gustav Robert Kirchhoff was a great German physicist who contributed to the fundamental understanding of electrical circuits, spectroscopy, and the emission of black body radiation by heated objects. Now we are going to learn about two of his laws, which are KCL and KVL. But mainly stressing about KVL, I'm just going to explain shortly about KCL. KCL, Kirchhoff's current law. KCL or Kirchhoff's current law is a fundamental law in electrical circuit analysis that states that the algebraic sum of the currents at any node in a circuit is 0. In other words, the sum of the currents entering a node is equal to the sum of the currents leaving the node. Here we can see in the diagram, O is the node and I1, I2 are entering the circuit and traveling towards the node, whereas I3, I4 and I5 they're getting out, they're leaving the node. That means according to the Kirchhoff's current law, summation of I equal to 0. That means I1 plus I2 minus I3 minus I4 minus I5 is going to give us a result of 0, which by taking these on the other side, I1 plus I2 gives us I3 plus I4 plus I5. This is basically Kirchhoff's current law. But today, however, we are going to discuss about KVL, which is Kirchhoff's voltage law. Kirchhoff's voltage law, KVL. KVL stands for Kirchhoff's voltage law, of course, and it is one of the most fundamental laws in electrical circuit theory. Here's a circuit diagram which consists of a voltage and also which is V1, which is basic RPM voltage, and we've got three resistors through which the voltage that passes as V2, V3 and V4, and according to Kirchhoff's voltage law, summation of V1, V2, so on Vn is equal to 0. Kirchhoff's voltage law states that the algebraic sum of the voltages in a closed loop is 0. In other words, the sum of the voltages around any closed loop in a circuit must equal 0. This law is based on the principle of conservation of energy, which states that energy cannot be created or destroyed, but can only be transformed from one form to another. Difference between KCL and KVL in form of pictures. Here we see Kirchhoff's first law, which is Kirchhoff's voltage law, which we again discussed, where the sum of the current entering the node is equivalent to the current leaving the node. So here I1 plus I3 gives us I1 plus I5 plus I3 equal to I2 plus I4, whereas in Kirchhoff's voltage law, which is second law, it gives us that E equals V1 plus V2 plus V3, the total voltage. So yeah, again in this picture we're given with another example where I1 plus I2 plus I3 equals I4 plus I5 plus I6, which is Kirchhoff's current law, and in Kirchhoff's voltage law, the voltage source Vs is equal to V1 plus V2 plus V3 plus V4 plus V5 plus V6 plus V7. Here are some advantages and disadvantages both of KVL, which is Kirchhoff's voltage law. Advantages of using KVL in circuit analysis includes 1. KVL is a powerful tool for analyzing complex circuits. It allows circuit designers and engineers to analyze circuits containing multiple loops and branches with ease. 2. KVL helps to ensure that the total voltage supplied by the source is equal to the total voltage drop across all circuit elements, providing a valuable check for the accuracy of circuit calculations. 3. KVL is a fundamental principle that is widely used in circuit analysis and is therefore an important concept for students and practitioners to understand. However, there are also some disadvantages to using KVL, including KVL assumes that all circuit elements are passive and that there is no energy storage or conversion. This means that it cannot be used to analyze circuits containing energy storage elements such as capacitors and inductors. Also, KVL assumes that the voltage across each circuit element is constant over time. This may not be the case in circuits with time varying voltages or in circuits containing elements with nonlinear voltage current characteristics. KVL can be complex and time consuming to apply in some cases, especially in circuits with a large number of elements or loops, which we are going to discuss in a while. These are just the advantages and disadvantages. Based on these, you can really check if you want it or not. But it really is a powerful and a really helpful device. So it's almost used everywhere. There are many applications of it. Let's just learn about the applications of KVL, which is Kirchhoff's voltage law. KVL is an essential tool for electrical engineers and technicians in analyzing and designing electrical circuits. Since it is very important, it has various applications. Here are some of the applications. The applications of KVL, which is of course Kirchhoff's voltage law again, are listed below. 1. Analysis of series circuits. In a series circuit, all the elements are connected in a line and the same current flows through each element. KVL can be used to find the voltage drop across each element in the circuit. Across each element in the circuit. 2. Analysis of parallel circuits. As there is series, there must be a parallel. So, in a parallel circuit, the elements are connected in parallel to each other and the same voltage is applied across each element. KVL can be used to find the total current flowing through the circuit. Here, there is another example with an image of KVL where we have a loop, the current that goes in that direction, and voltage V1 at R1, which is a resistance, and V2 at R2, and obviously V gives us V1 plus V2. This is pretty much it. That's very simple with KVL. Again, here's another application. Voltage regulators. Analysis of complex circuits. KVL can be used to analyze complex circuits with multiple loops and branches. By applying KVL to each loop in the circuit, the voltages and currents in the circuit can be calculated. 4. Voltage regulation in power systems. KVL can be used to calculate the voltage drop in power transmission lines and to determine the appropriate size of transformers and other equipment to regulate the voltage. Analysis of electronic circuits. KVL is extensively used in the design and analysis of electronic circuits. It is used to calculate the voltage drop across each component in the circuit and to determine the biasing of transistors and other components. 6. Analysis of circuits with multiple voltage sources. Kirchhoff's voltage law can be used to analyze circuits with multiple voltage sources. By applying KVL to each loop in the circuit, we can determine the currents flowing through each component of the circuit. 7. Calculation of voltage drops. Kirchhoff's voltage law can be used to calculate the voltage drops across each component in a circuit. By applying KVL to a closed loop that contains a specific component, we can determine the voltage drop across that component. Verification of circuit analysis. KVL can be used to verify the accuracy of circuit analysis. If the sum of the voltages in a closed loop is not equal to 0, then the circuit analysis is incorrect. Those are pretty much it when it comes to the applications. Now we can just see about a basic thing again, which is Kirchhoff's voltage law. The algebraic sums of voltages around a closed loop must be 0. In the image again we have a closed loop where there is a main voltage source and there are two resistors through which the voltage passing is V1 and V2. The current goes in a loop in that direction as they show us, and here draw current direction arbitrary and label the voltage direction determined by the defined current direction. Voltage on a voltage source is always from positive to negative end. Define either clockwise or counterclockwise direction as voltage drop direction. Once the direction is defined, you have to use the same convention in every loop. The sign for the voltage across a resistor plus if current direction is same as the loop direction otherwise. 3. Apply KVL plus V is if V is in the same direction defined above. Again, if epsilon, I guess that is epsilon, and minus epsilon plus VR plus V1 plus V2 equal to 0. According to Kirchhoff's voltage law, epsilon is equal to VR plus V1 plus V2, which again gives us I of R1 plus R2 plus R, which is I equal to epsilon by R plus R1 plus R2. They basically applied both Kirchhoff's voltage law and also Ohm's law. So yeah, that really is required if you need to find the particular value of current or voltage or resistance. So it depends on the what you need to find. Oh, surprisingly, there are more applications to KVL that, of course, totally, completely defines that KVL is very, very, very important in spite of having few disadvantages because it is used extensively. 9. Determination of unknown voltages. KVL can be used to determine the voltage of an unknown component in a circuit. By applying KVL to a closed loop that contains the unknown component, we can determine its voltage. 10. Analysis of AC circuits. KVL can be used to analyze AC circuits where the voltage and current are changing sinusoidally. By applying KVL to each loop in the circuit, we can determine the phase relationships between the voltages and currents in the circuit. 11. Analysis of transient circuits. KVL can be used to analyze transient circuits where the voltage and current are changing rapidly. By applying KVL to each loop in the circuit, we can determine the time varying voltages and currents in the circuit. I think by now we are pretty much done with the whole presentation, but we have a small thing at the end, but we are as of now done with the applications. Here are just summarizing the most important applications given with two different types of diagrams. Again, the first diagram which consists of two loops. Again, we should partially do it has series and parallel. We should consider both and we should add them and finally give the value required, which is the voltage, of course, or current, so to speak. And in the second, we have the famous Wheatstone bridge, where we have a galvanometer and it is very basic. So now let's just see the applications. They can be used to analyze any electrical circuit, computation of current and voltage of complex circuits. The Wheatstone bridge is an essential application of Kirchhoff's law. It is also used in mesh and node analysis, which are the other experiments which we've done already in the lab. After Kirchhoff's law is applied, each possible loop in the circuit generates the algebraic sum for every loop, which is V equal to V1 plus V2 plus V3 plus so on Vn. That is pretty much it. We are here now at the conclusion. The previously stated and given list of things were a detailed and also a summarized version of the applications of KVL, which is Kirchhoff's voltage law. Overall, KVL, Kirchhoff's voltage law, is an essential tool for electrical engineers and technicians in analyzing and designing electrical circuits. That was pretty much it from my presentation for the concept video AAT for basic electrical engineering. Topic was KVL, Kirchhoff's voltage law. I am Chupak Lalit Prem, 2295186216 CSE Cybersecurity. Thank you so much. Thank you.